Hello everyone, myself Professor Ashok Kumar. I am working in Department of Mechanical Engineering at Dr. Subhash Technical Campus. Look at the screen, today's chapter, that is chapter number 6 from subject Basic Mechanical Engineering, and chapter name is Steam Boiler Part 2. In my previous video lecture, we have discussed a lot on same chapter Steam Boiler as a part 1. So during that lecture, I have discussed about an introduction. I have also discussed about the classification of boiler, and at the end, I have also discussed about specially on Cochrane boiler. So now this is the time, or in this particular lecture, we will discuss specially on remaining portion or the remaining types of boiler in that particular lecture. So starting with the very much important boiler that we are going to discuss, and that is Babcock and Wilcox boiler. Basically, this boiler is firstly manufactured by Babcock and Wilcox company. So based on that first manufacturing of this kind of boiler, it is so named Babcock and Wilcox boiler. Now look at the screen. You have given two diagrams. One is the schematic, or actually the geometric diagram of Babcock and Wilcox boiler, where the bottommost diagram represents actual Babcock and Wilcox boiler, or physical model of Babcock and Wilcox boiler. Now, if you are looking carefully, there are numbers of parts which are mounted around and over the boiler shell. Suppose you require to classify this boiler, then Babcock and Wilcox boiler can be classified like that. For example, it is multi-tube, horizontal axis, of course, stationary boiler, internally fired boiler, water tube boiler, and so many. In that way, as we have discussed in my previous video lecture, classification of this boiler can be done. Now, look at the bottom portion of the Babcock and Wilcox boiler. There is a grate which is exactly placed at the bottommost portion of the boiler. Nearby grate, there is a one stoker. Actually, stoker is the kind of mechanism which continuously feed the pulverized coal. So that's why stoker is used over here, because this Babcock and Wilcox boiler is generally high pressure boiler, and it requires the large quantity of coal that is to be burned. So over here, a stoker mechanism which fits automatically required amount of coal quantity that is to be burned. We are using stoker for that. Exactly, there is a grate, and grate is basically a screening type of construction in which, or above grate, there is a preparation of coal grate. So ultimately, grate is a platform where there is a combustion of the pulverized coal is performed. Now, exactly below grate, there is a S pit. So whatever the combustion is taking place, and due to that the S quantity is formed, it will be by gravitational force or gravity force, it will be fall into these plates. That's why S, whatever the S that is formed is collected in particular space that is known as S pit, and from S pit it will be removed to other places. Now, exactly right hand side of the grate and S pit, there is two clean out doors. It name gives the function and the provision of that particular doors. It helps to clean the interior constructional parts to be clean out, need to clean at some frequent or periodic time. The man, or we can say that maintenance worker, can easily access through this both of the doors. That's why this clean out door is provided here. Now, exactly on right hand side, there is a one passage from which the whatever flue gases is produced due to combustion of pulverized coal over here. It will be after moving through various circuits of boiler. At the end, it will be get exhausted through this particular passage. So this is the exhaust passage of flue gases, and from this, it will be moved towards the chimney to the atmosphere. Now, if you are looking on the top of the grate, there is a inclined numbers of the tubes that is arranged over here, and that particular parts is known as we can say that it is an heat exchanger or evaporator. Now you can see that such type of numbers of tubes are arranged at both of the ends with the help of uptake and downtake header. So this is the header which actually assemble and collect both of the ends of the numbers of tubes. If downside header is there, so it will be known as a downtake header. And if the header is at the top surface of the tubes, inclined tubes, it will be known as a inclined, or we can say that the top header. Now you can see that there are in between the particular tubes, there are vertical plates are arranged in like that way. So actually it is known as a buffels. Basic function of buffel is to provide equal distance between all that inclined tubes, and other function to be fulfilled by the buffels is to provide the increase the length of the flue gases that is being passed through these evaporator tubes. Exactly above buffels and evaporator, there is a feed water that is going to be entered inside through these portions. So through this pipe or through this manifold or even we can say that a check valve, whatever the water available we have like from river, like from lake, is will be entered through this particular passage. So this is inlet of the water. Exactly feed water valve above which there is a water level indicator. Actually, it indicates the amount or the quantity of water present inside this particular boiler shell. So this is the kind of instrument which indicates directly the or which measures the amount or the quantity of water or water level present inside the boiler shell. Now, over the particular water level indicator, there is one more instrument is there, and that is the pressure gauge. Ultimately, its function is to measure the amount of the steam pressure that is generated in particular boiler. Now, beside that particular pressure gauge, there is a steam and water drum. Basically, this is boiler shell also. So this is steam and water drum, and this entire steam and water drum is basically divided by two parts. Bottom parts is generally known as a water space or water parts, and remaining top portion is generally known as a steam portion. So from that space, we can easily conclude that in case of steam and water drum, the bottom part, there is a water storage, and top half remaining portion, there is a steam space where the whatever steam or the amount of steam generated in evaporator will be collected there. So this is the very much important and essential part of any boiler, because it stores both of the quantity, input quantity as a water, and output quantity, that is a steam. Now exactly on the top surface of that particular water and steam drum, or we can say that the cell of boiler, there is superheated steam outlet. Basically, this is the these pipes provide the superheated condition of steam, and this is produced by using the superheater over here. Because whenever you are circulating water through this evaporator, and flue gases that is being passed out, around that particular tubes, of course water will absorb the amount of heat that is present inside the flue gases. In that way, as water moves in upward direction through these inclined tubes, it will become warm and hot, and at the end it may possible that the steam so form having the few amount of water drops, or we can say that steam has some kind of vapor content or water droplets. So in order to remove that water droplets from that particular steam, is the steam from the outlet of the evaporator will be stored first here, and it will be once again recirculated to this tube. Particularly, this is the superheater. Once again, there will be a heat transfer, and now steam absorb the fresh heat coming from the fresh charge by flue gases, and this time the vapor, or we can say that the wet vapor steam contains it's converted into a specifically superheated steam at the end. So over here you are finding the steam has superheated condition. Now after that, look at the side hole of that particular boiler cell. There is a manhole. The basic function of manhole is to provide easy to access of a person, or we can say that the maintenance worker, which can easily go inside the boiler cell and can perform the various maintenance work through this manhole. So that's why this is the manhole, and it is provided over here. Then after superheater, that we have already discussed basic function of superheater to remove the water droplet or the partial water content that is present at the uh, at the end of the evaporation process. Flue gases path, you can see that there is a flue gases path. Actually, this is the path in which the flue passing through and around the various inclined tubes in evaporator. We have also discussed about the downtake and uptake header too. Exactly below there is a mud box, and this mud box is provided at the bottom portion of downtake as well as generally uptake header. The basic function of a mud box is to collect the mud that is present in water due to mud may be the some impurities, some sediments if the present, and if water is circulating in that way due to a dense mass, that particular impurity or mud are by gravity collected in mud box, and from mud box it can be easily removed. So that's why mud box is provided here. Exactly below that mud box there is a blow up pipe. Actually blow up pipe or to blowing up, it means to get exhausted some impurity present inside it. We know that in mud box there is some mods for the deposits. It required to be exhausted, otherwise it will jam the entire passage flow of water in evaporator. So there is a provision of blow up pipe which will remove all the impurities which present in mud box. It's simply a cork kind of valve. If you are turning on it or turning it, the whatever the mud present, it will be get exhausted. So this is the mud box and the blow up cork. Now at the exactly below it there is a damper. See, damper is a kind of flue gas flow regulator. Look at this. This is the damper. Actually, it is the kind of door. If you are fully open it, we can say that whatever the flue gases or the amount or the quantity of flue gases that is being produced by burning the coal, all that quantity of gases are going to chimney through this damper if you are opening it fully. But suppose in some region you are opening it, damper it as a partially. So small amount of gas that will be going through this damper and pass inside the chimney. So basic function of damper is to control or regulate the amount of gas of flow inside the boiler cell. Suppose in some instant or some periodic time we need some maintenance work. So it may possible that maintenance work takes a few days of its maintenance of a boiler. So after the completion of that maintenance work, and if you are starting that boiler, then interior surface or all the parts due to maintenance work having the very low heat absorption at initial time. That means the initial temperature of all the parts that are mounted on boiler having very less amount of heat or the temperature. So initially, in order to start quickly this boiler, you need to recirculate again and again to all that interior parts so that they absorb the heat well, and in that way they initiate it. So in such a work, we require the damper opening and closing. Whereas in some cases, due to if a load demand or fluctuation of demand is producing by some region, we can use the damper opening and closing. So this is what about the Babcock's and Wilcox boiler. As what I said earlier, this is the real pictures of a Babcock's and Wilcox boiler. You can compare this with the diagram that you have given. This is actually a boiler shell. It will be having actually two sections. One is water section, other is steam section. This is actually, we can take the smoke box, and above smoke box there will be a chimney. So whatever the flue gas is that is ignited over here will be moved through various parts like evaporator and suppurator, and at the end it will be collected here. At bottom portion serves many parts platform like grate, clean out door, for example manhole. Look at the diagram, this is manhole, and there are numbers of instrument and devices especially which are mounted on different places, especially on boiler shell periphery. So this is about Babcock's and Wilcox boiler. Then after third types of the boiler, that is the Lancashire boiler. Actually, it is multi-tube because two tubes are being used. So multi-tube boiler, uh, higher tube boiler because in this type of boiler, flue gas is passing inside the tubes. It is a kind of stationary boiler because you can show that there is a masonry work, so it will not move easily from one place to other place. Generally, it is medium pressure boiler. So this is what about some classification based on different parameters. Now you have given three diagrams, three different view of the same boiler, Lancashire boiler. Look at the topmost diagram over here. There is a tubes in which at the left hand side there is a grate is provided, and above grate there is a, we can say that there is a pulverized coal bed, and this is the furnace door. Now exactly on the right hand side you have given a smoke box, or we can say that flue gas box. Over here, after circulating through various channels, flue gas is at the end collected over here, and through this part, it will be get adjusted through atmosphere. As we have already discussed in case of Babcock's and Wilcox boiler, similarly over here too, there are numbers of various mounting and accessory like safety valve, steam stop valve, clean out door, mud hole, manhole, pressure gauge, and all similar kind of instrument are also being used here. Look at actually this Lancashire boiler contains three primary channels. Channel, that means the way through which the flue gas pass. This is primary path. Main, it is so called main flue. And after passing flue gases through main flue, it will be diverted in downward direction. So this flue or this path, it will be known as a bottom flue. And after through passing in bottom flue, uh, flue gases will move towards the two channel, sideway two channel, and so that's why it is known as a side flue. So one may conclude that the flue gas is passing around and about water present inside the boiler in three ways. One is centrally, that is the main flue. One is at from the bottom side, that is a bottom flue, and the third channel through which the flue gases is passing past is known as a side flue. So ultimately, we can say that the water can get absorb the amount of heat produced that is present inside the flue gases in three side. So that's why it is very efficient boiler. Working principle is very similar. Actually, it is the boiler drum or boiler shell as that of the Babcock and Wilcox boiler. Over here too, this boiler drum is divided in primarily main two parts. One, the top half portion is known as a steam space or steam storage, wherein whatever the steam is to be produced is collected and stored over here, whereas bottom remaining portion contains the water space. That means the whatever the water that is required to convert into steam will be stored over here. And one more thing about that particular drum is that look at, there are two tubes exactly. It is located at the bottom portion, and over here there is a both of the particular this horizontal pipe contains the furnace and grate at the end. So over here this portion is look like this in case of front view. Now, by combustion of the coal, whatever the flue gases produce, it will move in the left to right side in case of main flue. And we know that around this tube there is a water, so water will get heated. It will become warm by absorbing heat present in flue gases. Once the flue gases has passed in main tube, it will move in the downward direction from right to left. That means in the bottom flue, and after completion of bottom flue path, it will move from the side flue. And once it is completed the entire way of the passing, it will be collected at the end of the smoke box, and from the smoke box it will be moved in chimney, and chimney through atmosphere. So this is the working and pass circuit of flue gases. uh, you can see from the figure that there are masonry work required to run this Babcock and Lancashire boiler, because masonry work is compulsory to accommodate this boiler set. And itself, masonry work provide the side flue and of course the bottom flue. So we can say this is not mobile boiler because it is not easily movable from one place to other place. Look at still more few diagram you have given above. This diagram represents the two pictures of Lancashire boiler. Look at, this is the tube number 1, this is the tube number 2. You can easily see that there is a actually this is the grate in which the coal is burning. This one is the S pit, and this is the fire door or furnace door through which we can supply the coal that is required to be burned. Now, apart from this, a few instrument and mounting necessary are also there. This is actually what we call it as a water level indicator. Uh, this is the feed check valve in order to feeding the water inside the water space of boiler cell. And this is masonry work. So this is what the real geometry of the Lancashire boiler. Over here you can see that there is a pressure gauge. So, dear friends, we have discussed in this lecture especially on two types of boiler. One, we have discussed a lot on Babcock and Wilcox boiler, and the later one we have also discussed on Lancashire boiler. One was that means Babcock and Wilcox boiler is high pressure boiler and water tube boiler, because in evaporator tubes water is flowing inside, whereas flue gas surrounds that tubes. Whereas in case of Lancashire boiler, it is purely fire tube boiler. That means flue gases moves around on the pipes of evaporator or flue pipes, whereas that tubes are surrounded by water. So this lecture, in that particular lecture, we have discussed two types of boiler. Kindly stay tuned with us. I hope that you have getting well through this my video lecture. Uh, Still, few boilers and the mounting and necessary are required to be discussed. That will be covered in my next upcoming video lectures. Thank you for kind of attendance. Thank you. Thank you very much.